Hello students, and we are returning to Article 230.70. This is going to be a very short video on the remaining part of Article 230. Basically for those of you whose class was unexpectedly interrupted the other night. So let's just dive into it, get through it. You guys can get on your way. We're talking about service disconnects for the service equipment. Okay, and the code refers to it under 270.30 general rule as the means shall be provided to disconnect all conductors in a building or other structure from the service entrance conductors. So we've got the utility lines coming down, right, to our service entrance conductors, and now they're coming down or coming up depending on whether or not we are underground fed or overhead fed. And they're now passing through the meter, and they now need to be controlled. We have to be able to open and close those conductors and terminate the energy flow into the system. Okay, so what we want to do then is, well, we just got to kind of get an idea of what does all that look like. One thing very important, 270A talks about the 230.70A, talks about the location of where these are to be. And it says the service disconnecting means shall be installed in accordance with 230.70A1, A2, and A3. A1 talks about something that you should be very familiar with by now, being readily accessible. The service disconnect must be readily accessible. What does that mean? You must be able to basically walk up to it, open or close it at will, without any obstructions in your way, without having to climb over or duck under anything. It's just that easy to get to. Readily accessible. Number 2 is bathrooms. Service disconnects shall not be installed in a bathroom. And remember, the definition of a bathroom is any room with a basin and one of another type of water feature, such as a toilet or a shower or a tub, anything like that. So we don't want to have service disconnects in the bathroom. Obviously, it probably means somebody tried to put one in a bathroom at one time, and of course the authorities having jurisdiction and the NEC committees got together and went, yeah, that's not a good idea. The other part, part 3, deals with remote control. You are allowed to have remote control. A lot of times for safety reasons, you might not want to be at the service disconnect. It might be easier to control it remotely. However, the service disconnect itself, even though you're controlling it remotely, the service disconnect itself must still be readily accessible. Okay, that then brings us to the marking. B, letter B. Each service disconnect shall be permanently marked to identify it as a service disconnect, right? And I've told you before, you get questions about does something have to be marked, labeled, of course it does. This tells us what it needs to be marked as, right? It needs to be identified as a service disconnect, not just a disconnect. Okay, also it must be suitable for the use that it was going to be applied to, right? It says each service disconnecting means shall be suitable for the prevailing conditions. Service equipment installed in hazardous classified locations shall comply with the requirements of Article 500 through 517. Basically, Chapter 5 or Article 500 is dealing mostly with hazardous locations. What are hazardous locations? I'm not going to go into it in great detail, but there are divisions and classifications. So generally we have 3 classifications, and each one gets a little more dangerous than the other one, or I should say it starts out with the most dangerous one and goes downward. So classification 1 is explosive vapors. And then we have explosive dust and we have explosive fibers. And division 1 versus division 2 is locality to where that problem might actually exist. Like division 1 means you're like right there with the explosive vapors, and division 2 means you're close to where that problem might be, where the explosive vapors could be, or dust or fiber, whichever one of the three classifications we are talking about. Enough about that. Okay, that brings us to Article 230.71. 230.71 is the maximum number of service disconnects. Now, it says the service disconnecting means for each service permitted by 230.2 or for each set of service entrance conductors permitted by 230.40 exception number 1, 3, 4, or 5, okay, shall consist of not more than 6 switches or sets of circuit breakers. Okay, so, or even a combination of those. Okay. Now that does not mean just, we know with the NEC we're going to have exceptions, and it's not really an exception per se as it is, we understand that we have to have additional disconnecting means sometimes. We talked about this earlier, right? The fire pumps, you don't want them on the same disconnects that you going to have with the normal 6, because when the firefighter shows up and he starts clicking all those switches off, right, to kill power to the building, you don't want him killing the fire pump. Okay, that's like definitely one thing we want to keep going, obviously, if you want to put out the fire. Other things we'd want to keep going as well would be emergency backup systems for like life support at hospitals, or just things like that. Because of that brings into play 230.72, the grouping of the disconnects, right? So not only can we have these additional disconnects, but we don't want them next to the 6 disconnects, right? We want them removed a ways from them so the firefighter does not accidentally click them off, or whoever it is that's turning them off does not accidentally click off those vital ones that we just talked about. Fire pumps, right? Or emergency systems, legally required. If you look in B, right, 230.72B, you'll see where it says additional service disconnecting means, and it says the one or more additional service disconnecting means for fire pumps, emergency systems, legally required standby or optional standby services permitted by 230.2 shall be installed remote from the 1 to 2.6 service disconnecting means for normal service to minimize the possibility of simultaneous interruption, like we just talked about. Do not want that to happen. Okay? Now, that then brings us to C, access to occupants. The other thing we have to consider is, what if you're renting space, right? You have to, as a person of a multiple occupancy, be allowed to have access to your disconnect, right? However, they can forego that if there is continuous management in place. And continuous does not mean what one student told me. He goes, 3 hours? No, continuous means continuous, right? Non-stop management, because you as a renter have the right to be into the property that you are occupying, and you must be able to control or have some sense of control that which is taking place at, if you need to kill power to work on the system there, or, you can't wait all the time till, somebody else comes and opens up at, 8 o'clock in the morning or 9 o'clock in the morning. So they have to have continuous management, somehow that you can get in contact and they can go, okay, yes, we'll take care of that. We'll turn off the power, or we'll turn on the power. Okay? That brings us to 230.74, the simultaneous opening of poles. And it says, each service disconnect shall simultaneously disconnect all ungrounded, and remember ungrounded means hot, okay, all ungrounded service conductors that it controls, okay? So we just want to make sure that, you know, we don't turn off and only, you know, one of the hots goes off. You know, we got two legs, or maybe we've got a three-phase system, and the last thing we want is only one of those or two of those turning off. We want all of them to turn off, so we know that it's safe to proceed. Right now, remember, even though you think you turned them off, I'm going to always emphasize safety. Remember, treat it as if it was still on. You guys know my personal story. I messed up. I don't want you to mess up. Okay? 230.75, the disconnection of the grounded conductor. Now remember, grounded conductor, not grounding conductor. This is not the equipment ground conductor. This is the grounded conductor, aka many times referred to as the neutral. Okay? This is the grounded conductor, and we must have a way of disconnecting it. The code says, where the service disconnecting means does not disconnect the grounded conductor from the premises wiring, other means shall be provided for this purpose in the service equipment. A terminal or bus to which all grounded conductors can be attached by means of pressure connectors shall be permitted for this purpose. In a multi-section switchboard or switchgear, disconnects for the grounded conductor shall be permitted to be in any section of the switchboard or switchgear, provided that any such switchboard or switchgear section is marked, so we know what we're dealing with, right? We don't like surprises. Now, if you caught that, what we just read, and I know, you know, sometimes you guys get confused with the words grounded and ungrounded and grounding, okay? Remember, we're talking basically the neutral, right? Technically, the grounded conductor, but for most of you, you think of it as the neutral, okay? Now, the grounded conductor, we have to have a way to disconnect it if we're going to service the system. Okay, and we're going to run into other means, but the reality is we don't ever disconnect the neutral without disconnecting the ungrounded conductors first. So we want to make sure that, or simultaneously at the same time, right? But remember, it's very dangerous. You don't want to disconnect that grounded conductor, aka neutral, and leave those hots or the ungrounded conductors energized. Because if you do, you're going to cause a lot of damage. Okay, some of you in code A saw what happened when Mr. T, or maybe it was in code B, where he opened up the neutral and you had lights flickering, and that's kind of a bounce effect of because you know they're not perfectly balanced circuits or sides, right? And you imagine on a large scale, if you were to do that to like a factory or something like that, you would knock out some really expensive equipment, okay? Because one would be getting a power surge, you know, like down in code A, if we disconnected it, one leg would all of a sudden drop to about 60 volts and the other leg would jump up to like 180 volts or 160 volts, and you can imagine a computer trying to run on 160 volts. That's not a good thing. So, you know, just remember, we want the ability to disconnect the grounded conductor, but it has to take place after we disconnect the ungrounded conductors or simultaneously with the ungrounded conductors, right? But never disconnect it while you still have energized ungrounded conductors or HOTS hooked up. 230.76, manually or power operable. The service disconnecting means for ungrounded service conductors, your HOTS, shall consist of one of the following: a manual operator of switch or circuit breaker equipped with a handle or other suitable operating means, so you can turn it on and off manually, or a power-operated switch or circuit breaker, provided the switch or circuit breaker can still be opened by hand in the event of power supply failure, right? Still want to be able to open that circuit, right? Or I should say that service. Okay. 230.77 indicating the service disconnecting means shall plainly indicate whether it is in the open, the off position, or the closed on position. Okay. 230.79 rating of service disconnecting means. The service disconnecting means shall have a rating of not less than the calculated load to be carried. Obviously, we do not want the load, that's the draw of power coming through, right? Remember, load is draw. We don't want that to be greater than the rating of our service disconnect. Otherwise, we're going to be tripping our service disconnect all the time. Now, under that same section, we have A, B, C, and D, and they kind of give us the sizes, the minimum sizes of what services can be. So if it's a one circuit installation, you have a single circuit, right? You can have a 15 amp service. Two circuits, you can have a 30 amp circuit. And then it jumps. C says a one family dwelling, right? And it says for one family dwelling, the service disconnecting means shall have a rating of not less than 100 amps. Not less than 100 amps. Okay, so yes, there are old services out there that on homes that are less than, right? But we're talking really, really old homes, and they were less than 100 amps, not allowed anymore. Okay, if you do a panel change, you will definitely have to make sure you're doing at least a 100 amp service. I recommend on any homes that you're doing, do 200 amps. But that's not what the code requires. Code requires 100 amp minimum for one family dwellings. And then we have D, all others. And this is kind of a little weird one. It says for all other installations, the service disconnecting means shall have a rating of not less than 60 amps. That's all others, not less than 60 amps, right? And think about what all others means. What are we talking about? Well, anything other than a one family dwelling, a single circuit, or a two circuit. That's all others, which would tend to make you think even factories, only 60 amps? Yeah, you're not going to see that. Okay. And let's see. 230.81 is where we are going to wrap it up with. Well, actually, no, we are going to quickly just mention 90 because it segues into your overcurrent protection that we were talking about in Article 240. But 230.81, and I guess we will cover 82 as well. 230.81 says connection to terminals. The service conductor shall be connected to the service disconnecting means by pressure connectors, clamps, or other approved means, but connections that depend on solder shall not be used. Okay, solder melts at too low of a melting point. Okay, and so we don't want to use it. 230.82 talks about equipment that can be connected on the supply side of the service disconnect. Remember, we talked about where that is. The supply side of the service disconnect would be from the service drop down or lateral up, our overhead service conductors or our underground service conductors through the meter to the service disconnect, right? Okay, somewhere in there we can have equipment connected, and there's special ones that we can have. We can have cable limiters or current limiting devices. We can have meter socket disconnects even. In fact, we want to make sure that no one uses a meter disconnect as a service disconnect, and they are labeled as such. And if you read in your book and look down there in number 3, you'll notice it says a little section that says meter disconnect shall be legibly marked, field marked on its exterior in a manner suitable for the environment as follows. Big bold letters, meter disconnect, not service equipment. Okay, 230.90, really quick, finish it up here, and I'm just going to kind of briefly hit it just to let you know. It says, where required, overcurrent protection, where required. Each ungrounded service conductor shall have overload protection, right? Meaning we're going to protect it from too much load being drawn through it, causing too much heat to build up, right? So that's A, and now B talks about something very important, and we're going to finish up, I believe, with this, or actually maybe one more thing. Yeah. B says not in the grounded conductor. Remember, grounded conductor again is our aka neutral, right? The grounded conductor. And it says no overcurrent device shall be inserted in a grounded service conductor except a circuit breaker that simultaneously opens all conductors of the circuit. Meaning it's going to open not just the neutral, but it's also going to open the hots, or the ungrounded conductors, all at the same time, right? Because remember, we don't want to disconnect that neutral, leaving the hots energized or the ungrounded conductors energized. The last thing I think we're going to finish up with, yes, this will be the very last thing, is 230.95, ground fault protection of equipment. Okay, ground fault protection of equipment. It says ground fault protection of equipment shall be provided for solidly grounded Y electric services more than 150 volts to ground but not exceeding 1,000 volts phase to phase for each service disconnect rated 1,000 amps or more. Now, I'm not going to get into a whole lot about that, but the part I really want to emphasize is this is ground fault protection of equipment. This is not your GFCI. This is not going to trip at 5 milliamps or 6 milliamps. These things don't even begin to trip till 30 milliamps, which is dangerous for you, because remember, at 10 milliamps your muscles start to cramp up, and by 30 milliamps you're having trouble breathing. Okay, so I bring that up because I don't want any of you out in the field see this sign up there and then go, oh wait, wow, okay, I don't have to be cautious, it's got GFCI. No, it doesn't. It has ground fault protection of equipment. Okay. If you drop down to letter A, 95A, you'll see it says ground fault protection systems shall operate to cause the service disconnect to open all ungrounded conductors of the faulted circuit. Okay, and it says the maximum setting of a ground fault protection shall be 1200 amperes, and the maximum time delay shall be 1 second for ground fault currents equal to or greater than 3000 amps. Then I want you to jump down just one down to letter C, and the one thing I just wanted to stress, and this is the very last thing and we're done, is ground fault protection systems shall be performance tested when first installed on site. So that brings us to the conclusion of 230. You have now been brought up to speed with those other students, the part that you missed the other night. I'm sorry that happened to you. Please continue checking into the classroom and checking emails, and don't forget, we're working this out for you. We want you to be a success.